Hi students, we will learn about Hofmann rearrangement. This is a rearrangement to electron deficient nitrogen. Amides which do not have a substituent on nitrogen display a molecular rearrangement called as Hofmann rearrangement on treatment with alkaline aqueous solutions of bromine or chlorine to give primary amines. In this rearrangement, the carbonyl carbon atom of the amide is lost and the R group of amide gets attached to the nitrogen of the amine. So let us see the rearrangement. So here we have first Hofmann rearrangement is nothing but the conversion or rearrangement of an amide to the amines. So there is nothing but the rearrangement in which the amide gets converted to the amines. Now the first step is nothing but this is going to be taking place in presence of a base catalyzed reaction. So we have an hydroxyl group. First step is hydroxyl group is going to abstract the proton of the amine group. Now when this happens, nitrogen is left with a negative charge. So it's becoming an anion. Now at this position, this anion can react with other compounds, like here we are going to take the bromide. So you can also use the halides like other halides like chloride also. So here what happens, it is going to, the N minus lone pair on the nitrogen is going to grab the bromine, one of the atom of bromine, and there's nothing but the release of the other Br as Br minus. So now here this is going to give rise to an intermediate of this kind, wherein a bromide is attached to the amine group, to the nitrogen group. Now what happens, the OH minus, since it is taking place in a base catalyzed, so we have a base already present in the sufficient base present in the solution. So now again another OH minus is going to grab the proton of the amine. Now here it is forming a secondary amine. Now again it is going to grab the proton from the nitrogen. Now here again you're going to get the N minus. So when N minus is there, see here N minus is formed here. That is the nitrogen has a negative charge on it. At this point, the bromide is again going to be eliminated. See here what happens is, first step was the addition of bromine, and again this next step is going to be the elimination of the Br minus. Now Br minus is going to be eliminated. That is here, what we have written is here, Br minus is going to be eliminated. Now, this intermediate that is formed, right, it is going to, here there's going to be the rearrangement. See now when you look at the electrons, count the number of electrons around the nitrogen, you can see that it is 6 electrons. 6 electrons are present around nitrogen, and hence we also say that Hofmann rearrangement is rearrangement of an electron deficient nitrogen, because the nitrogen should have 8 electrons around it, and here it is having only 6 electrons. So at this stage there is going to be the Hofmann rearrangement. That is nothing but the ethyl group along with its electron pair is going to move towards the nitrogen. That is being shown here. So it is nothing but formed here. That is that the ethyl group along with the electron pair attaches to the nitrogen, which is formed here. You can see here. Now, the next step would be, now the conclusion is nothing but we should find the reaction for the amine. That is nothing but an H has to be attached to the nitrogen. So we have to proceed along that direction. Now the next step would be, there's a lone pair on nitrogen. It is going to move towards the carbon to form a double bond between oxygen and carbon to give the isocyanate. And here you can see the carbon is having a positive charge. So that has to be eased. So that can be removed only when there is a double bond between the carbon. So this is the isocyanate group which is formed here. Now again the OH group is going to attack the carbonyl carbon, because carbonyl carbon is highly electropositive when you because it is attached to oxygen and nitrogen on either end. Now the lone pair, that is the double bond of the carbonyl carbon and oxygen, moves towards oxygen to give a negative charge on oxygen. It is nothing but an intermediate of this kind is going to be formed. Now there has to be the removal, or the lone pair on the oxygen has to come back to form a double bond to give a ketone group, carbonyl group, and there is nothing but the movement of the double bond between carbon and nitrogen and moves towards nitrogen to give a negative charge on nitrogen, like this. Okay, now the next step is nothing but the lone pair on nitrogen is there is a proton here, H. The OH is having the hydrogen proton. Now the N minus is going to grab the proton, H plus, and the oxygen, the lone pair, there is a bond between the oxygen and hydrogen, moves towards the oxygen to give a negative charge on oxygen. Now there has to be the elimination of carbon dioxide. That is nothing but how it is formed is the negative charge on oxygen moves towards the carbon to give a CO2 group that is going to be eliminated, and the N, that is the nitrogen, was forming 3 bonds, that is one with carbon, one with the ethyl group, and one with the hydrogen. Now the bond is broken between the carbon and nitrogen, and lone pair moves towards the nitrogen to give N minus and ETH. Now the last step would be the formation of the primary amine. So how that is formed is that there is water molecule. Now the N minus, that is the lone pair on nitrogen, grabs the proton of the water molecule and OHs moves away. That is how we are going to get the OH minus, and we are going to get the primary amine. So this is how the Hofmann rearrangement takes place. So wherever you come across a rearrangement with electron deficient nitrogen, wherein the amide is converted to amine, it is nothing but the Hofmann's rearrangement. Okay, so thank you very much.